Today we're going to learn about translations of exponential functions. G of x is equal to a times b to the x minus h plus k. So this is the general form for an exponential function. And the translations occur through the plus k and the minus h. So if there were no translations done, then the function would instead be g of x is equal to a times b to the x power, because we're disregarding the minus h and plus k for the translations. So if we had a function like this, what would it look like? Well, let's say our function, f of x, is equal to 2 to the x. In this case, let's try to graph this here. And so we're going to have a graph that looks something like this. Now I moved over our function f of x over here, but now we're going to find the points for g of x is equal to 2 to the x minus 3. Now here I started at g of 1 and ended at g of 6. What you might notice is that all the values line up with the function f of x. The only difference is that the value of g is 3 more than the value of f. So for f of negative 2, we have 1/4, and for g of 1, we also have 1/4. The difference being 3. The reason why is because the function g of x has x minus 3 here. So if we were to graph this, it looks something like this. This is g of x is equal to 2 to the x minus 3. And we see that quite simply, the graph has just been translated to the right by 3 units. And that reinforces what this horizontal translation says. A horizontal translation is b to the x minus h. In this case, minus h is minus 3. And so all the values are behind by 3 units, which is why you need a greater value of x in order to have equivalent values as the function f of x. So now that we know that, we don't really have to solve for all the points on g of x is equal to 2 to the x minus 4, because now we know that the second function here is a vertical translation. And because it's negative 4, it's going to translate vertically down by 4 units. So if we take this parent function, the white one that we made, take all the points and translate them 4 units down. So the function is going to look something like this. This is g of x is equal to 2 to the x minus 4. Now the final function is g of x is equal to 2 to the x minus 2 plus 3. So this is a combination of a vertical and a horizontal translation, which means that we just have to identify the translation. So plus 3 means that it's going to be plus 3 units vertically, and the x minus 2 means that it's going to be horizontally translated plus 2. This is something you're going to have to get used to, as vertical translations are straightforward in that a plus 3 means increase in 3, but a minus 2 for the horizontal doesn't mean that you're translating it to the left. It's actually the opposite, and it's to the right. So because we have a horizontal translation of plus 2 and a vertical of plus 3, all we need to do is take the parent function, which is this white one, horizontally translate by 2 and vertically translate by 3. So this function is going to look something like this.